Assalamualaikum and good day everybody. Welcome to our first class in our course of Engineering Analysis. In today's class, we will discuss an important area that has a huge impact on engineering analysis and made the Industrial Revolution 4.0 possible. Let me introduce you to the world of simulation, or in engineering analysis terms, computer-aided engineering. I hope you can join me until the end of this video. You are welcome to ask questions and comments in our Google Classroom. Okay, moving on to our learning objectives for this video. By the end of this talk, you should be able to explain the role of CAE in engineering design process. You should be able to also explain the technology used in CAE. And the last one is you should be able to explain also the advantages and disadvantages of CAE. Let's look at the traditional engineering design process in detail. It is a sequential process where each process advances one after the other. This is also known as over-the-wall process. If you can imagine a wall that separates each process from one another. So, the first process that we are going to encounter is the planning process. This is where the organization will finalize the project brief and all the research regarding the target market, user demographics, product budget, customer requirements, and target specifications are gathered and finalized. Then we move on to concept design, where the designers will use all the information gathered at the planning stage to produce concepts and design alternatives as a possible solution to the project brief. Meetings and discussions among the organization will determine which of these possible concepts are to be further developed. Moving on to the next process, the detailed design process. Here, the selected concept is then passed over to the engineers, where the concept is studied in greater detail to determine the feasibility of the design in terms of manufacturing and product performance. Then the prototyping team will take the lead. Here, they will produce actual prototypes to be tested against specifications whether it meets it or not. Now, between the design and prototyping phase, it is an iterative process, meaning that it is a continuous cycle back and forth. Compromises will be made between designers, engineers, and the management until the deadline arrives and the project is to move forward. So after the buy-off stage by the stakeholders, it is then sent to the production team to run a pilot production test. This is to see whether the design is able to be produced in large quantities. Finally, mass production will commence afterwards. Okay, now we look at the technology involved in today's engineering design process. We can see a lot of software applications that have been used by each process. You can see the concept design we have CAID, or Computer Aided Industrial Design, where this software is used by the designers to create the digital concepts and mockups, and then the output will be processed by CAD, CAM, and K. CAD, or computer-aided design, is where the engineer will detail out the concept in terms of product architecture, product manufacturing, and product assembly. CAM, or computer-aided manufacturing, is where the engineers will evaluate and formulate machine manufacturing instructions or programs. Example, like a CNC machine needs G-code instructions on how a part is to be machined. And then we have computer-aided engineering, which is our main topic for this course. This is where the engineers can simulate how the product performs in the real world without even using a physical prototype. This will reduce the cost of the organization in terms of verifying the design before going for mass production. And all of this is controlled by a software called ERP, or Enterprise Resource Planning. This is where the company's resources like manpower, raw material, machine capability will be monitored. This shows how technology has been integrated in today's manufacturing process. Okay, now let's look at the role of CAE in the design process. Computer-aided engineering is the use of computer software to simulate the performance of the product in order to improve the design or facilitate solving engineering problems for various industries. As you can see, the keyword here is to simulate. The application of the software may include simulation validation and optimization of product processes and manufacturing. If you look at the diagram below, we can see that the real-world domain is on the left side and the digital world is on the right. Simulation in this context is the intersection between these two worlds, if you can see here in the dark blue colored area. The simulation world is where the real world and the digital world combine. So the role of CAE is to provide simulation to check whether the product will survive in the real world or not. Okay, now let's move on to the core technology of CAE. The core technology is called Finite Element Analysis, or in short, FEA. The finite element analysis is the simulation of any given physical phenomena using the numerical technique called finite element method, or FEM. FEM is the mathematics that govern the FEA software. Engineers use it to reduce the number of physical prototypes and experiments and optimize components in their design phase to develop better products faster. Combination of the latest hardware and software is used in CAE. So, to sum up the slide, the core technology of CAE is FEA. So, you will hear this term FEA a lot when you are in the field of CAE. Basically, FEA is a software that uses computers to take the digital form of the product and run tests on it according to the type of analysis needed. As you can see on the left, we have various products that have been analyzed using FEA. From the top, you can see there is the pipe. It is tested for pressure. And the next one is the steel frame tested for strength. And the last one, a plastic clip to test the snap fit mechanism of the part. Okay, now moving on to the next slide. Here we can see various CAE softwares that are available now in the market. HyperWorks, ANSYS, Abacus, MSC Software and COMSOL are considered high end of the market. There is also other open sourced software which is free to use, for example OpenCascade. But we need customization in order for it to work properly with our own needs. Another software that leverages cloud computing is SimScale, which is a fully cloud simulation software. In our course, we are going to use CATIA's generative shape design. In the next slide here, we see the types of analysis that can be done by CAE. The first one is a linear and nonlinear static analysis. This analysis is the most common and used by the industry. This is the fundamental analysis that can be done, which serves as a baseline for the product being tested. The next one is a dynamic analysis. Here, moving forces, product movement, and inertial forces are taken into account. The next one is thermal analysis. This analysis deals with heat transfer and thermal effects on the product. For example, if we design a refrigerator, we can see and analyze the cooling efficiency in each compartment of the refrigerator. Fluid statics and dynamics analysis involves the simulation of gas and fluid forces. For example, the strength of a boat hull in rough seas or a high-pressure vessel like a submarine in the deepest waters. The electromagnetic analysis is a very popular test in the telecommunication and mobile devices industry. For example, we can test the signal pattern of your phone, whether the signal transmission is good or not. And the last one is the crash and drop test. This is a popular analysis done in the automotive and consumer product industry, where we test the strength of the product during a crash or a drop. Now we will move on to CAE benefits. The first one is product development costs and time are reduced with the improvement of product quality and life. Next is computer simulation-based design will substitute for the physical prototype testing and provides cost and time savings. CAE can give insights about the performance of product prior to the development phase and when design changes will be less expensive. CAE provides information regarding the risk and reliability engineering of the product design. Maintenance cost is reduced by identifying and eliminating potential problems. When properly integrated into the product design and manufacturing development, CAE can enable earlier problem identification, which can dramatically reduce the cost associated with product wear out. There are also several drawbacks to CAE. The first one is the cost of acquiring software is really high. The next one, the specifications of the hardware, meaning the computer or the equipment used to install this software, is demanding and requires high startup costs. This might not be cost effective for small or medium-sized industries. And the last one is the software is garbage in, garbage out, meaning mistakes made by a non-experienced user can remain undetected. Finally, as a conclusion, CAE plays an important role in modern manufacturing process as the simulation platform, where the product is tested virtually in the digital environment. The next conclusion that we can make is the main technology used in CAE is the finite element analysis or FEA, which is a software to create the simulations. Then there are many advantages of CAE, where most of them will contribute to improving time and cost to produce the products. As a final conclusion, we can also say that there are some drawbacks to CAE, including high startup costs, and also the level of user knowledge and experience will determine the effectiveness of implementing finite element analysis in their processes. Thank you for joining me today. Don't forget to leave your questions and comments in Google Classroom. Until the next video, this is your lecturer, Hafiz Muhammad. Assalamualaikum and see you in the next video. Thank you.